You know, um, usually when we think about a cyber attack, we picture like a burglar picking a lock on a single house.
Right. It's a very isolated event.
Exactly. They break in, steal the valuables, and leave. But what if instead of targeting one house, the burglar goes after, well, think of it like a flour mill.
Oh, yeah, the supply chain.
Yeah. It's like poisoning the flour at a major mill rather than trying to poison individual loaves of bread at 1,000 different bakeries.
It completely changes the scale of the threat. I mean,
Yeah.
you aren't just compromising a single victim anymore. You're weaponizing the very infrastructure they rely on.
Right. And the worst part is the victims are willingly bringing that flour into their own homes.
Yeah, they're installing it themselves.
Which is exactly what we are looking at today.
Yeah.
Because if you wrote a line of code today or, manage a tech team or honestly, if you simply use software built on modern infrastructure, there is a very high probability your digital foundations are under an automated self-replicating siege right now. It is Tuesday, May 19th, 2026, and we are dissecting a stack of 3 urgent cybersecurity reports, 3 massive supply chain attacks that are just breaking today.
And while they might look like isolated incidents hitting different platforms at first glance, as we dig in, they weave together, they create this deeply concerning bigger picture. We're really watching the automation of compromised trust across the entire open source ecosystem.
Okay, let's unpack this. We're going to look at how threat actors are hitting the source of software distribution, starting with a campaign known as Mini Shai-Hulud.
Right, the NPM registry attack.
Exactly, which is essentially the central library where JavaScript developers download code packages.
Yeah, and the volume of this first attack is really what grabs your attention. So threat actors managed to compromise a single highly influential NPM maintainer account.
Just one account.
Just one. It's an account known as a tool, and it is heavily tied into the @NTV ecosystem.
Right, and for those working in data visualization or, graphing, the blast radius there is just immense. I mean, one of the affected packages alone, Eckhart's for React, that pulls in roughly 1.1 million weekly downloads.
Yeah, it's huge.
And compromise didn't stop at NTV namespace, right? It bled over into other widely used packages outside of it, like timego.js.
Yeah, and canvasnest.js too. What's fascinating here is the methodology. I mean, this wasn't a manual slow burn infiltration where a hacker carefully hides their tracks over weeks.
Right.
The attacker published 639 malicious versions across 323 unique packages.
Wow.
And they executed that entire rollout in a highly targeted 22-minute burst.
Wait, hold on. 22 minutes. Hear what you're saying about the scale, but how does an attacker manage to hijack hundreds of packages and push updates in just 22 minutes without triggering massive alarms immediately? Where were the automated defense systems?
Well, it's a great question, and it really speaks to how much trust we inherently place in authenticated accounts. Because the attacker had a valid maintainer token, the system basically just saw an authorized user updating their own software.
So it's like a thief stealing a master key. Instead of just opening doors, they use the key to instantly manufacture thousands of new compromised locks and mail them to everyone in the neighborhood.
Exactly. That 22-minute window tells us this was a fully automated, self-replicating worm. They just triggered a script that abused the NPM registry API.
And what did that script do exactly?
In seconds, it enumerated every single package that the maintainer owned, downloaded the source code, injected a malicious payload, bumped up the version numbers, and republished them all.
That is terrifying. Let's talk about the execution mechanism on the victim's end, because that's where this gets really insidious. They use something called a pre-install hook. Can we break down why that's so dangerous?
Absolutely. So most developers know that when they type npm install, they're downloading code.
Right.
What isn't always top of mind is that you are also giving that code permission to execute lifecycle setup scripts on your local machine, like immediately.
So it runs on its own.
Right. A pre-install hook runs automatically before the package even finishes installing. So the attacker just weaponized that invisible automation.
So the moment you pull the dependency, the payload is already running in the background.
Exactly.
And this payload is incredibly aggressive. It harvests over 20 different types of credentials. We're talking AWS, Microsoft Azure, Stripe data, database strings.
Yeah, GitHub tokens, Kubernetes secrets. It even tries to escape Docker containers.
Wow. And then it takes all that, right, encrypts it, and exfiltrates it to this external domain, tm-kausha.com.
Yes, but the creepy part is the fallback mechanism.
Right. Tell me about the fallback.
If that primary domain gets blocked by a firewall, the malware takes the GitHub tokens it just stole and programmatically uses the GitHub API to silently create a brand new public repository under the victim's own account.
Under the victim's account. So they're basically hosting their own stolen data.
Exactly. It commits all their stolen, encrypted data into a JSON file right there out in the open.
That is wild. And they tag it, right?
Yeah, to make it searchable later, they tag these repos with a reversed description string. It says Shai Hulud. Here we go again, but spelled backward.
And Step Security actually found over 2,500 of these repositories sitting on GitHub.
Which is critical because that 2,500 number isn't just a random stat. It represents the absolute minimum lower bound of unique compromised environments.
Because each repo means a successfully stolen token.
Right.
Now, as if dealing with an automated worm isn't enough, there is a major twist here. The financially motivated threat actor behind this, Team PCP, they actually released the source code for this worm on Breach Forum.
Oh, yeah.
A contest.
Yes. And Datadog and Trend Micro warned that this drastically lowers the barrier for copycats. We're already seeing the fallout, actually. An unknown actor has already uploaded 4 cloned packages.
So the supply chain weaponization is basically open source itself now.
Yes.
Okay, so that's the NPM attack. But the destination of all that stolen data, that tm-kosh.com domain, that is the thread that unravels our second story. Because researchers spotted this exact same exfiltration domain in a completely different attack vector.
Yeah, this is where we shift over to the GitHub Actions compromise. Threat actors managed to hijack popular workflow actions, specifically Actions Cool Issues Helper, and maintain one comment.
And teams plug these directly into their CI/CD pipelines, right?
Exactly. They use them to automate repository maintenance. And the technical brilliance of this attack relies on a concept called an imposter commit.
Okay, let's define what that means in Git history.
So in a normal repo, you use tags to point to specific stable versions, like at v1.0. It's a shortcut. What the attackers did was move every existing tag in the repository so that the pointer is redirected to an imposter commit.
Okay, wait, so is this like an author slipping a malicious fake chapter into a book after the editor has already approved the final draft, but before it goes to the printer?
That is a perfect way to visualize it.
The table of contents still says Chapter 5, but the words on the page are completely different.
Yes. And because the tags themselves were redirected, the attackers completely bypassed standard pull request reviews and code checks. The imposter commit only existed in a fork they controlled.
Oh, wow. So any workflow just asking for version 1 automatically pulls the malicious code.
Exactly.
Okay, so what does the payload actually do inside the pipeline?
It's remarkably efficient. Once it executes, it immediately downloads the Bun JavaScript runtime.
Wait, let's pause on that. Why Bun? Why not just use Node.js, which is probably already there in the environment?
That's a deliberate evasion tactic. Bun is a lightweight, self-contained executable. By downloading Bun, they don't rely on what the host has installed, and more importantly, they evade security tools that are specifically watching Node.js for suspicious behavior.
Oh, that's clever.
Yeah. And once Bun is running, it directly reads the memory from the runner, worker process.
It's just scraping the active memory.
Exactly. That process handles all the environment variables and injected secrets. The malware just strips the credentials right out of memory and ships them straight to that same tm-kosh.com server.
Unbelievable. And only workflows pinned to a known good full commit SHA were safe?
Right, because the SHA is immutable. The tags are not.
Okay, so attackers are hitting NPM registries and CI/CD pipelines. The logical next step is hitting the developer's desktop before the code even gets pushed. And that brings us to our third source. We're talking about the compromise of the Next Console VS Code extension.
Yeah, specifically version 18.95.0. This is a very popular UI plugin with over 2.2 million installs.
And just yesterday, May 18th, during a brief exposure window, developers opening any workspace silently executed a 498 kilobyte obfuscated payload.
Right. They didn't click a link or run a build, just opening the editor initialized it.
And how did that get in there?
It was an orphan commit. A developer's credentials had been leaked in a prior incident, and the adversary used that to hide a dangling commit in the official NRLS GitHub repository.
So it's invisible to casual inspection.
Exactly. And the payload is a multi-stage stealer harvesting 1Password vaults, Claude code configs, and on macOS, it installs a Python backdoor called cat.py.
And it's not acting alone. Reports mentioned a staggering list of other concurrent threats, stuff like the Noon Contracts crypto stealer, The common TG service, Telegram hijacker, and even LLM proxies.
Yeah, it's a massive coordinated assault, but there is a specific core threat that connects the NPM worm and this NetX console attack. It's the most dangerous evolution we've seen. SLSA, provenance forgery using Sigstore.
Okay, here's where it gets really interesting. Because I have to push back a little here. If the artifact has a valid cryptographic signature attached to it, doesn't that fundamentally mean the security system is working?
Wow.
I mean, how can a signature be forged if the underlying math is technically valid?
If we connect this to the bigger picture, it explains a critical nuance. You have to look at what the signature is actually verifying. The malware in these campaigns mints legitimate OIDC tokens.
Wait, let's define that. What is an OIDC token?
It's OpenID Connect. It's an identity layer. The runner uses it to cryptographically say, I am the official GitHub Actions runner assigned to this repository.
Okay.
The malware hijacks that identity. It forces the runner to mint a valid token and then uses it to sign the malicious payload.
So the signature itself isn't faked.
No, the signature is absolutely real. As Ender Labs noted, the attestation perfectly proves where the package was built.
It proves the build environment, but it does not prove the build was actually authorized.
Exactly.
Let me try an analogy. It's like an attacker putting a gun to the head of a legitimate notary public. The notary stamp is real, the signature is real, but the document they were forced to stamp is a total fraud.
That is the exact scenario. The runner stamped its official seal of approval on the malware. It makes legitimate releases indistinguishable from malicious ones.
They've weaponized our own verification tools against us.
They really have.
So what does this all mean? If you fall in the blast radius of these tools, GitHub Actions, VS Code, NPM, what do you need to do right now?
You need to rotate credentials, all of them. GitHub, AWS, 1Password, Claude API keys.
And audit GitHub for those Shai-Hulud marker strings. Right?
Yes. Delete disk artifacts like vartmp.updatestate, and please pin your workflows to commit SHAs.
Right, because these campaigns are built for massive credential theft, turning the tools you trust into the vehicles of your own compromise.
Yeah, it's that compromised flour mill.
Exactly. Which leaves us with a lingering, provocative question to ponder. If our entire open source ecosystem relies on a delicate chain of trust, and attackers are now automating the forgery of the cryptographic signatures of that trust, how do we redefine what it means to trust software without grinding global development to a complete halt?